For a while now, we have been solving example problems using the idea of conservation of mechanical energy. Conservation of mechanical energy says that if there is a process in which only conservative forces act, then the change in kinetic energy during that process plus the change in potential energy during that process is equal to zero. Now we would like to ask if this statement is still true if we have a process where non-conservative forces are acting. In other words, can we still say that change in kinetic energy plus change in potential energy is equal to zero if we are looking at a process where non-conservative forces act? We can answer this question using a quick demo. I'm just going to take a mass, and then I'm going to give it a push. And you can see that after the mass left my hand, it slid along the table and then came to rest. Why did the mass stop? The mass stopped because there was friction acting between the mass and the table. Friction is a non-conservative force. So in that demo, we actually saw a process where a non-conservative force is acting, and we can ask ourselves, for that process, was it still true that change in kinetic energy plus change in potential energy was equal to zero? Okay, I'm going to sketch that out. So we had that mass. I gave it some initial speed. Then friction acted between the mass and the table, and then the mass came to rest, and then the final speed was zero. So let's ask if change in kinetic energy plus change in potential energy was in fact zero or not for that process I just showed you. Well, what was the change in kinetic energy? Well, the kinetic energy decreased. So the change in kinetic energy was negative. What about the change in potential energy? Well, did gravitational potential energy change? No, because the mass was moving horizontally. What about spring potential energy? Well, there were no springs, so there were no changes in the potential energy. So the change in potential energy was zero. So what was the change in kinetic energy plus the change in potential energy? Change in kinetic energy plus change in potential energy was a negative number because kinetic energy decreased and potential energy did not change at all. So for a non-conservative force, we cannot say that change in kinetic energy plus change in potential energy is zero. Okay. So what do we do? Well, it turns out there is an equation that looks almost exactly like this, and which is always true even for processes where non-conservative forces are acting. So I'll show that to you. So the version of this, which is true even in processes where non-conservative forces act, is this. Change in kinetic energy plus change in potential energy is equal to the work done by non-conservative forces. This statement is always true no matter what kinds of forces are acting. Now, in this class, the only potential energies we encounter are gravitational potential energies and spring potential energies. So, for the purposes of this class, we can say change in kinetic energy plus change in gravitational potential energy plus change in spring potential energy is equal to work done by non-conservative forces. And this would be if the only conservative forces acting are the gravitational force and the spring force, which would be true for any problem that comes up in this class. So we now have a version of a mechanical energy equation which we can use even in situations where non-conservative forces are acting. And in the next video, I'll show you an example of how we can use this to solve a problem.